Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 3, Lesson 19. Let's get started. If you were working on this in class, please pause the video now and complete opening exercise that you see here, and then we'll come back and show you the solution. All right, so here is what we're doing with this problem. We have a coordinate plane. Our job is to find the distance between the points using absolute value. So first I need some ordered pairs. So I'm going to find the ordered pairs for these given points. If I start from the origin and I go 4 units to the right and then 3 units down, I get to that first point. So the ordered pair is 4, -3. And let me change my pen, that's a little bit too big. Okay, 4, -3. And then my other point will be 4 units to the right and looks like 5 units up. So 4, wow. I just said 4 and wrote 5. 4 to the right, 5 up. So there's our 2 points. And then using absolute value, what we notice here is that the x value is the same in both points. So I don't worry about the x value. They're both 4. What I do want to look at is the y value. And in this case, the y values are different. So I need to look at where they are on the number line. And I see that I have a -3 and a +5, which means they're on different sides of the number line. One's positive, one's negative. So from yesterday we learned that if I take the absolute value of -3 and I add it to the absolute value of 5, I will get my answer, which is 3 plus 5, or a distance of 8 units. And we know that this one is a vertical line because we can see it here if I graph the 2 points. And let me see, I gotta make a dot there. And then drew this. There's our line. It's a vertical line, but we also know that from the ordered pair because it was the y value that changed, and y always tells you up or down, so this is a vertical line. 8 units. All right, let's go to the exploratory challenge. Okay, please pause the recording and answer questions 1 and 2 of the exploratory challenge, and then come back and we'll check the solutions. So here we are with the solution for the exploratory challenge, where our job is to locate and label the points 4, 5, and 4, -3, and then draw the line segment between the endpoints. So first thing we'll do is find these points. I'm going to go 4 to the right, and then 5 up. And let's see, I think that's going to be right here. Whoops, let me get one that you can see. 4 and 5, looks like right there. And then 4, -3 is 4 to the right, down 3, so right there. And then our job was to draw a line segment between those 2 points. So I'll do that as well. And there we have it. We've got 4, 5, and 4, -3, and the line segment in between them. The question is, how long is the line segment that you drew? And we could look at the graph here and see that we've got 5 spaces above the x-axis and 3 spaces below the x-axis, and we could add those together to say that it's a distance of 8. We can see it right here. That would be a distance of 8. Or we can take a look at our changing values, which I see are a 5 and a -3. So since they're on opposite sides of the number line, I remember that the absolute value of 5 plus the absolute value of -3 is equal to 8. So either way we could find that distance. Number 2, draw a horizontal line segment starting at 4, -3 that has a length of 9 units. And what are the possible other endpoints? Well, if I'm going to go 9 units, I can go in a lot of directions. I could go 9 units to the left. That would be 4 and 5 more. So there. I could go 9 units down. 5, 6, 7, 8, 9 would be down here somewhere. I could go 9 units down. Could go 9 units to the right, which would be over here in some fashion. Could go 9 units up, which would be one higher than where it is there. So I could draw this line segment in a lot of different places, and let me show you what they would look like. Could have a line segment right here. That's a possibility. Could have this line segment here. That's a possibility. Could have a line segment right here. Right there. So there's another one. And then I could also have this one that goes back up to the top. So any of those are possibilities. You would have your X value would change if you're having this line segment or this one. Your X value is going to change because since that's an X change in X, left and right. Or if you drew the line segment down or up, then your Y value will change accordingly. Okay, so there are a lot of possible answers. And so let's take a look at what one or maybe a couple of them might be. If I move 9 units to the left, then my X value, wrong tool, then my X value is going to be 9 units smaller than 4. So that's going to put me at -5. And the Y value would stay the same. So there's a possibility if I move to the left. If I move it to the right, then my X value is going to be 9 bigger than 4, so that's 13. And the Y value stays the same. If I move it up, then my X value is going to stay the same, 4, but my Y value will change. It'll go up 9, so 3 plus another 6, so I'm going to be at +6. So 4, 6. And if I move down as the other possibility, my X value stays the same, and my Y value would change by getting more negative. 9 more negative is -12. So there's your possibilities. All right, let's go to number 4. We're going to use the vertices that you've found and the lengths of the line segments between them and find the perimeter of the rectangle. So pause right here, go ahead and do that, and then also number 5, find the area. All right, I've taken the rectangle that we formed by drawing the vertical and the horizontal line and brought it over here, copied it over. So we knew that the vertical line here was 8 segments, and the horizontal line, if we changed it by 9, was 9 segments. So we have the dimensions of this rectangle. And then we know that perimeter is the distance all the way around this object. So I'm going to add 2 of the widths of 9 and 2 of the lengths of 8. And that will give me the perimeter. That's the distance all the way around. 2 times 9 is 18, plus 2 times 8 is 16. Add those together. The perimeter is 34 units. Okay, and then to find the area, you have to remember that area is equal to length times width, and that's the space inside of here. This is the area, the space inside, and so we would do 9 times 8, which is 72, and those are square units. All right, come back to part 2 of this lesson, and we'll finish out lesson 19. We'll see you then.